Hi, in this video we'll be talking about the properties of real numbers. So there are certain things that you are allowed to do when working with numbers and certain things that you're just not allowed to do. Or there are certain things that are always the same, and those are the things that we're talking about. So those are what we call the properties. Alright, so the first property that we'll be talking about today is called the commutative property. Alright, let's write that down so you know how to spell it. Alright. So the commutative property, when I think about the commutative property, I think about commuting. So for example, traveling, you're traveling to work or traveling to school. You can do the same thing when you're adding and multiplying numbers. So let's say, for example, you have an expression, 8 plus 4 plus 3 plus 1. It doesn't matter if I have the 1 at the end of the expression, or if I have the 1 at the beginning of the expression, so 1 plus 8 plus 4 plus 3, or in the middle of the expression somewhere. It doesn't matter at all. So it could still be 8 plus 4 plus 1 plus 3. So all of these things are the same because the 1 or any number or any variable can actually travel from one place in an expression to another, and it does not change the value. So this is true for addition as well as multiplication. All right, so let's move on to our second property. So the second property that I want us to talk about is called the associative property. All right, so when I think of the word associative, I actually think of the word associate. So for example, I associate with my friends at school or my friends at work or my friends at home or my family. So association, like I'm talking about how you group yourself, who you hang out with basically. So for example, I could have 3 plus 4 plus 5, and in parentheses the 4 plus 5, and of course, you know, order of operations, you would do the 4 plus 5 first because it's in parentheses. But if we're just dealing with addition, it doesn't matter how I'm grouping the numbers. So 3 plus 4 plus 5 is the same as 3 plus 4 plus 5. So notice I've grouped the numbers differently, and it does not matter. Same is true for multiplication. If I had 3 times 4 times 5, it doesn't matter if I have 3 times 4 times 5 or 3 times 4 times 5. So it doesn't matter who, for example, this 4 is associating with. The 4 could be hanging out with a 5, or the 4 could be hanging out with a 3. The values are actually still the same. So that's the associative property. All right, so let's talk about the next. Okay, so now let's talk about the reflexive property. And this one is kind of a tough one to remember, but it's pretty simple when you know what it is. So the reflexive property sounds like the most obvious thing in the world. Think about when you're looking in a mirror. If you're looking at yourself in the mirror, what do you see? Well, you should see yourself, the reflection of yourself. So if a variable A is looking at itself in the mirror, it's going to see the same thing. It's going to see itself. So what point or purpose could this possibly serve? I'm sure you're asking yourself that question. Well, let's say you have a word problem and it says, it describes one thing in one way. It says, okay, Miss Hamilton's age is 3 plus x, and Miss Hamilton's age is also y minus 2, then you know that 3 plus x and y minus 2 is the same thing. So I'll say, using my name, Miss Hamilton's age is Miss Hamilton's age, and that's such a long little thing here. And it doesn't matter how I describe Miss Hamilton's age. It doesn't matter if I describe Miss Hamilton's age as h, or if I describe it as x plus 2, or if I describe it as y minus 4. Regardless of how it's described, it's always going to be equal to each other. So this is a really, really useful thing when you're solving word problems. Sounds super obvious, but trust me, very helpful when you know it. Okay, let's keep going. All right, so the next property that we're going to look at is the symmetric property. And a lot of people mix up the reflexive property and the symmetric property, but they are different. Okay, so the symmetric property says that if A is equal to B, then B is equal to A. So I can't tell you how many times I've heard students say, does it matter if I put the equation, the X on the left side or on the right side? It absolutely doesn't matter. So if you had an equation, X plus 4 is equal to 10, for example, and for whatever reason you really wanted or needed to rewrite this equation, and you wrote it as 10 equals X plus 4, does that matter? Does not matter at all. These two things are the same because of the property, the symmetric property. All right, let's keep. All right, so we have something called the transitive property. And I like the transitive property. It allows you to do things in geometry and in algebra that you wouldn't otherwise be able to do. You'll see what I mean. So let's say A is equal to B. Let's say B is equal to C. Well, if A is equal to B and B is equal to C, then, lo and behold, A is actually equal to C. That's the transitive property. And I remember the transitive property by thinking of the word transfer. You know, I'm transferring from one value to the next and then the next value to the next. So overall, A is equal to C. I don't know if that helps you, but it certainly helps me. So I thought I'd share. All right, let's keep going. All right, the next property that I wanted to talk about is the identity property of addition. And think about that word identity while I'm writing. Of addition. All right. So when you think about your identity, what are you thinking about? You should be thinking about yourself. If you're thinking about your identity, you are thinking about who you are, yourself. All right. So you are an individual. A number is its individual number. If you add something to that number and it's still itself, what did you add? Well, the identity property of addition says that if you add 0 to a number, then the number stays itself. So it has not changed its identity. By adding 0 to x, we still have x. In a similar way, and I'm actually going to use the same page for this because they're very, very similar. Let's think about the identity property of multiplication. All right. So, if I have a number x and I multiply it by a certain thing, it's still going to be x. What can I multiply x by and still get an answer of x? If you said 1, then you are correct. So according to the identity property of multiplication, then x, a number times 1 will always be equal to itself. So those are the two identity properties. Let's keep going. All right, so we're almost to the end of these properties, just a few more. So I wanted to talk about the property of opposites, and it's exactly what it sounds like. So let's say we have a number 5, and we add a number -5. So those numbers are opposites, additive opposites. When you add those opposites together, you get 0. And it doesn't matter what two opposites you add together. So if you had x and you added -x, you'd also get 0. So when you're adding opposites, you will always get a 0. All right. You can do that for addition. I meant to write addition. Hold on. You can also do that for multiplication. So writing this whole phrase again, property of opposites. I'll just write op. For multiplication, I'll just write mult. All right, so for multiplication, the opposites are reciprocals of each other. So for example, x and the reciprocal of x, the opposite of x for multiplication is 1 over x. Whenever you multiply opposites, you always get the value 1. Always. It doesn't matter what x is, and it doesn't matter what what the number's opposite is, whenever you multiply a number by its multiplicative opposite, that was hard to say, the answer is always 1. So this one is the property of opposites of addition. We always get 0. This one, property of opposites for multiplication, we always get 1. Just remember that the opposite for addition is sign. We are focusing on the positive versus the negative, and the opposites for multiplication are the reciprocals of each other. All right, let's keep it moving. All right, so addition, property of 0. I bet you can figure out what happens here, but we'll still go over it. Addition, property of 0. It's actually basically the same as the identity property of addition. It says that if we're adding 0, we're always going to get the same thing. But slightly different is the multiplication property of 0. These are long phrases. Okay, so you probably know where this is going, but I'll still go over it. If we multiply a number by 0, any number by 0, the answer is always the same. Multiplying a number by 0, so let's say 7 times 0 will give you 0. A billion times 0 would give you 0. Negative 33 times 0 will give you 0. It doesn't matter. As long as you're multiplying by 0, you'll always get 0. Adding 0, you'll always get the original number. All right, so that's all the properties that we'll go over today. Hopefully these properties and knowing them and really getting them ingrained will help you as you move forward in your journey in algebra.